All right, thank you much. Thank you very much. So Jim Bergmann here with Measurequick. Wanted to do a little bit of a interesting topic tonight. Actually, a couple things we're gonna do. I'm gonna go over a little bit on just some of the things we're doing at Measurequick, a little bit of history behind this. I just think it's interesting to see where we've come in the last couple of years and where some of the technology is, just give you guys an idea of what's out there and what's available. So I've been actually doing stuff with digital manifolds probably since their inception. The first real, Imperial had some digital stuff back in, if you remember 1989, if you went downtown to downtown Cleveland, they actually had a set of Imperial digital gauges that were in the case, in the glass case in the front. For years they had them in there. Those were actually not digital gauges, they just had digital displays. They were a board-on tube with strain gauges built in, and took an analog signal and made it into digital. It's just the first digital display. Doug Lockhart and Digicool, about 1993, actually filed for the first patent on the Teresa, is what they call the digital system, digital refrigeration system analyzer. And I always thought this was funny because they didn't analyze anything. It was just a gauge with a pretty cool patented bar graph on there. That was this real big claim to fame, was the way the bar graph pulsated back and forth. You said you could determine if you had a system that was hunting or flooding or different characteristics. It was just a really highly amped up signal on the gauges. When Doug came out with those, they did not even have temperature probes on them. He was doing all the analysis by watching pressure. It was before really did a lot with subcooling. Robin Air 1999, I remember those came out. They had the first digital set. You put the batteries in them and let the smoke out. They really didn't work too well. There was a company, AC Door, 1998, and then it was owned by Peter Behrens in Germany. Peter Behrens is actually the guy that developed the first digital gauge sets that Testo actually acquired right around 2005. And that's sort of when I got involved with the first digital gauges. I was actually speaking at when I was in the high school program. They sent him in, John Feigen, I don't know if you know John Feigen from Testo, he came in and he's just showing me all these tools, and I looked in his trunk and he had this digital gauge set bouncing around the back of his truck, and he goes, so John, what's that? And he goes, it's a digital refrigeration manifold. He goes, but it's like $1,200, nobody's ever gonna buy it. He was just crazy. And they said, well, how about leaving with me for a couple days so I can play around with it? So I brought it into the lab, and I think, was it you and Nathan Barnett? Yeah, wow.
That was in 2003, 2004.
Okay, yeah, so.
And I still have those.
Yeah, so Jimmy and Nathan Barnett hooked it up, and I just handed it to them because it was going back to some of the DOS computers just about, and we figured out pretty quickly it didn't calculate superheat right, didn't calculate subcooling right.
Huh.
The Germans, when they built it, they forgot this little thing called atmospheric pressure. So all the gauges, all the calculations were off by a saturation temperature of 14.7 PSI. But what made it was really confusing was it actually used an absolute pressure sensor built onto the board. So as the barometric pressure was changing, the numbers were changing, and we had a hard time figuring out if it was barometric pressure because
every time somebody opened the door, it would jump.
yeah, well, we just didn't know. You know, it's back before we realized how some of this stuff worked. So Jimmy and Nathan actually helped me pioneer some of this stuff. I forgot about that.
Never forget the manual was in German.
2011, Fieldpiece came out with their digital manifolds, and then Hillmore in 2013. Hillmore came out with this, and it was interesting because they think they took a play out of Imperial's books. They actually used servo stepper motors for the gauges. So this is what happens when you design by committee. Hillmore came out and they asked everybody, what things do you want? And they said, oh, we want an analog and digital. We want analog feel, but digital look to it. So that's what they built. And when they came out with it, you power up the pressure transducers, and they go click, 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 all the way up. If you took the pressure off, it took about 30 seconds to get back down to zero. So it was an interesting concept, poorly executed. Prices dropped on these things, and then we go from really some of the first wireless tools. Bill Spohn and I worked for Testo at the time. and we were telling them, hey, we really need wireless, more wireless tools. So the first attempt was a 435 around 2005. And when they presented it to us, the first thing I did was check out the range, which was about 15 feet, 10 to 15 feet. And I said, guys, we want a wireless. They go, Jim, there is no via. It's perfect. I'm like, no, you completely misunderstood what we want. We want like long range wireless. And they literally thought eliminating the cord was what we were asking for. A little failure of translation on there. Redfish 2007 came out with the first wireless IDBM. It was intelligent digital voltmeter. Talked to the smartphone. I actually bought this company right before I started Measurequick. I bought it for the patent. It's bi-directional communication for Bluetooth. So basically, there was no display on that meter, and everything was controlled to the iPhone application. So when you told the meter to switch, it switched the relays and then fed back the voltages. And that's the patent I still own today that we use for Measurequick. Sold the hardware business for that to Supco about a year ago. And then if you remember the service assistant, FDSI, that was really one of the first digital gauges that didn't have a display on it. It was an app-only interface, and it talked to what? Anybody remember? No? The Palm Pilot. Yeah. So this actually communicated with our Palm Pilot, and it never, I think they got an app for that before it died, but it's gone now too. Analysis came out with a product in California. This is one of the first actual air conditioning refrigeration system analyzers. And these capture hoods went out, and you put the capture hood on top of the condensing unit. And it measured the airspeed out of the condensing unit, basically how many BTUs of heat were rejected. And they were analyzing how the air conditioning was performing. Very expensive. You can see it's got a computer with a modem tied to it. Never really took off in there. Get Cool, 2007, developed by Buck Taylor. And then along came us around 2014 with the iManifold. It was actually the most awarded product that ever on the digital manifold side. We actually won 9 awards on that. Jimmy was with me, helped actually build that one too when he left Benvenue. We designed the hardware and the application in 1 year. Got that 1 year to market, and we had a little falling out with them. Wireless probes, Fieldpiece came out with their own little hub. It was 915 millihertz transmitter. Basically, it tied into your, tied the gauges in and talked to your smartphone. Testo Smart Probes 2016. These were actually, believe it or not, and I should have put it in there, but iManifold actually pioneered the wireless probes, because when we came out with those humidity probes, then we came out with manometers, and we came out with pressure probes. Testo and Fieldpiece just figured out ways to make them cheaper and tie them in with Bluetooth directly. And then Testo came out with a whole, Fieldpiece came out with a couple cool products, and Testo really came out with a full line. Hot wear anemometers, vane anemometers, manometers, hydrometers, thermometers, infrared thermometers, and it really started to take hold on there. And then, really the most modern stuff right now is the Fieldpiece probe, but there's a lot of others, Yellow Jacket, UEI, Parker, Sauerman, JD, and again, prices just continue to drop on the technology. And then around 2017, we came out with Measurequick, and now we're in version 2, 2022. And so the whole idea behind this is really connecting all these tools and technicians and the owners together, right? And so we're going to answer a few of these questions here. And
real quick, Jim.
Yes, sir.
Back to that list you had of all the other probes. One more. All those others down there. Those all work with the.
So not all of them work with them. There's just others. I don't think any on the bottom. We're talking to JB right now, and I don't think anything else on that list we work with right now. So there's a handful of other products out there, but the Parker's Foreman probes we do work with.
What's the multimeter? Isn't that UEI?
UEI makes one. Redfish makes one, and
The one you got,
Fuel piece makes, and talk to it.
the one you got in the kitchen.
We don't support UEI, yeah. Yeah, we've had, it's interesting when you get into this, and you're trying to look what products you're gonna build out and support with this, and, cause none of the manufacturers, with the exception of AccuTools and maybe AccuTools and I think maybe that's it, has ever given us any information on how their products work. We actually reverse engineer them. So we look at what data comes off of them, parse it out, figure it out. With their permission and blessing, but a lot of these products are made, a lot of these companies don't make their own products. So Testo's probably an exception. I think Fieldpiece makes their own products, but a lot of the companies have product contract manufactured for them, so they honestly, I think, don't know how some of the stuff works. So they come to us and say, want to incorporate it into Measurequick. We ask them for documentation of how it works, and they say, you just have to figure it out. Yeah. So we do a lot of the reverse engineering of the products. All right. So when you're talking to industry today, I think a lot of us don't realize it, but the biggest problems we have are airflow, duct leakage, followed by refrigerant charge and improper evacuation. And the last actually are installation and maintenance related issues. You know, we're gonna funnel, you know, these are, airflow and duct leakage are by two of the biggest problems we have in the industry. There's been several studies done. This one was done by Pacific Northwest National Laboratories, and it said HVAC installations have a fault in 70 to 90% of homes. So 7 to 9 out of 10 homes have a fault. And when you consider duct leakage, it goes to 90 to 100%. This is a DOE study in 2018. For air conditioning and heat pumps, that energy use is increased by 9% over ideal installation. And it really came down to this, is inadequate refrigerant charge and insufficient evaporator airflow in 50 to 72% of systems. So when you're looking at in the residential segment, 50 to 72% of them don't have correct charge and airflow, right? Fixing those two faults alone is a 5 to 10% decrease in residential cooling loads. Same sort of study, this was done by NIST, and it was a sensitivity of analysis of heat pump faults. And again, they found duct leakage, refrigerant charge, equipment sizing, low airflow. And low airflow is often due to oversizing the equipment on the ductwork. It's a very common problem. Refrigerant overcharge and resulting thermostat setting. And just to put this in perspective, if you think about like a consumer, the only control they have is the thermostat. So if they're not comfortable, they're gonna turn the thermostat down. Doing that in Texas, like just taking it down 2 degrees in Houston, Texas, increases your energy bill by about 20%, right? So it's just sort of a insanity. We're doing the same thing over and over again, expecting some kind of different result. And the question you gotta ask yourself, if you're going out these jobs, are you finding them that way or leaving them that way? And realistically, what we're finding over and over again is the amount of opportunity that technicians leave on the table because they can't identify the faults, even have the opportunity to present them to the building owner, the homeowner, whatever they are. You think about what we do for a living, you know, if you can't find that problem, you never have the opportunity to present it, you're leaving a ton of revenue on the table. And it's not that every time somebody's gonna fix something, but if they never even know it's broken, they don't even have the opportunity to say no, right? This is where we really get the problem. Yep. Checklist Manifesto, right? Old Grande. Surgeon. It's an interesting book, and the whole thing. It's not a bad manifesto like Jimmy's thinking. Was that when we get into real complex problems, we need a checklist, right? And a lot of companies use checklists. It's a pretty common thing. But here's the issue: is checklists, they just cannot be trusted, right? I used to work for one of the larger HVAC mechanicals in the Cleveland area, close to Solon. Terry was there once for a few weeks. At one point I was put in charge of all the younger guys to help be tech support for all the rooftops and that kind of stuff. And I remember on a Monday morning walking into the office and walking up to one of the trucks, and the guy's sitting in his desk, sitting in his truck seat, and he's writing down, filling out a check sheet. I'm like, hey, what are you doing? He goes, oh, didn't get a chance to fill this out on Friday, I'm just filling it out now. I said, you remember all the readings from Friday, huh? He said, oh yeah, I remember them all, I got a pretty good memory. So he's writing down pressures and temperatures and superheat and subcooling. I said, let's go up the, come here and sit down for a minute. So I just pulled out a psychometric, temperature pressure chart, and I said, what was your pressure reading? And what was your temperature reading? That superheat just doesn't add up. Let's look at the subcooling. It seems like you don't remember too much of this stuff. And he was just pencil whipping his paperwork. You start going back and looking at all the invoices and all the stuff and all the incrimination the guys were doing. They were literally copying down other guys' invoices or check sheets. And sometimes it was for non-nefarious reasons. Somebody wanted to learn a control system, and they were going out to a job that had the control system, but they were supposed to be out checking 24 rooftop units. And they felt like they were never getting the time on the control system, so they're there quarterly. Somebody else is checking them, and they copy down the check sheets and record them. This kind of stuff happens all the time, right? And we gotta realize that when I got out to the job the first time, I'm finding 29, 30 problems on a job, and I'm thinking, okay, this is happening way more than we think it is. So, we couldn't do it. They don't give a real-time picture. There's nothing to remind technician. Here's an interesting thing. You can give your technician all the best tools in the world, but you have no idea when they make a measurement what the response is to what that measurement is. Do they just record it? Do they do something with it? Do they take some kind of action? Anderson Heating and Air Conditioning up in Avon, one time I was up there, one of their technicians recorded high CO level on a new startup on a piece of equipment. It got inadvertently, it was over Thanksgiving, it filed away. Lady ends up with CO poisoning, right? Again, it doesn't make sure that something got done, right? So checklists are really not the answer. We're in a part right now in a study with Pacific Northwest National Laboratories. They're looking at, I don't know if you guys are paying attention at all, but anybody know what's happening in New York and California right now? Aside from the liberals are going crazy out there.
I'm not from there, I haven't been there.
We're live right now, we gotta be careful what we
So,
say.
we're on Facebook Live, somebody just shut us off, but it's okay.
Whatever it is, I can do it.
Yeah, well, we're eliminating fossil fuels. They don't want natural gas in California, they don't want natural gas in New York, and we're gonna heat the world with heat pumps, right?
And what about the natural gas supplies that make the electricity in California? No natural gas, don't make electricity. Let's use electric cars. Solves the problem.
You and what
Well,
grade?
yeah, it's, if you really think about it, Phil, if everybody installs a heat pump, it will combat global warming, because we'll just pull all the heat from the outside,
Air conditioning
put it
outside.
into homes, and then it won't be an issue anymore.
Except that it's gonna heat the ground with the water source.
Yeah.
Shoes are gone, we may be able to save the trousers.
Yeah. So, but the issue we're having right now is with 50 to 70% of systems not having correct charge and airflow, these heat pumps aren't gonna do the job. We just don't have an adequate labor force to properly install this stuff and have it work successfully. To put this in perspective, all right? NREL did an estimate on central air conditioning and heat pump waste. 20.7 terawatt hours of energy due to equipment faults. 20.7 terawatts. Now, if you wanna put a visual,
Megawatts in a terawatt.
if you wanna put this to visualization, okay? So annually, right, if we were to take the volume of Lake Mead, if you ever seen Lake Mead, at its highest level, we would pump over 5.7 times the volume of Lake Mead over the Hoover Dam, which is approximately 8.5 trillion gallons of water, which is 9% of our energy consumption, or about 2.5 billion. Right? So we're talking about a substantial amount of energy waste. This is just on the residential side, due to improper installation, improper airflow, improper
These are
charge.
systems people think are running.
Well, they are running, they're just not running well, right? So, a little bit on when we're talking about connected tools, we're talking about wireless tools. They can be Wi-Fi, Bluetooth, or Zigbee that connect to a device, they go to an app that interpret the data and make intelligent decisions, okay? we're talking about the tools, we're talking about job link, field piece, the energy conservatory, top coat, glue on. Glue on's not an app, but I do wanna cover that for just a second, AccuTools. And just a little bit about these tools. Field piece, we use a lot of in Measurequick, and the reason we like them is because they beacon the signal. So we're using field piece probes in an educational setting, like if you guys were all in here, you have one set of probes connected to one piece of equipment, and everybody in the room can connect to those probes at the same time. That's a huge advantage when you're trying to do training, is being able to let everybody connect and see what's going on. Testo's probably got the most exclusive line of stuff. It's got a very clunky German application, but they do make some of the best measurements in the industry. They've got really high-end quality probes. Redfish meter we've got that ties in. It's actually was the first meter that actually would do some analysis of some of the components, and it allowed us to bring it into the application and do voltage drop tests, service and utilization voltage tests, test components like thermocouple flame rods, start capacitors, run capacitors, that kind of stuff. It was really the first industry's diagnostic BOM. And then obviously Bluevac, which we're heavily involved in. We've got the application for that to help do vacuum diagnostics. You guys have seen that in the past, and a little bit what we're doing on that end. Just recently, Energy Conservatory came out with a product called the Digital True Flow Grid. I don't know if you guys are aware of this, but this is actually makes a volumetric measurement of airflow across a coil. So if you want to really dial in the airflow, the application not only makes the airflow measurement, but it also does your total external static pressure, your filter pressure drop, your coil pressure drop, supply pressure, and return pressure. Now, you go, well, why would we even want to measure that? Well, every one of these things has a target zone, right? So we're looking at all of these different pressure drops in a system. We have a static pressure budget we typically design for, and the software helps you analyze what part of the system you're having a problem at, so you can make the corrections. And then if you don't have blue on, and the only reason I mention this, if you're gonna make a measurement, you really need to know what the measurement's supposed to be. And one of the problems we have in the industry today is, especially when we're talking about things like static pressure measurements, is, how does it relate to the fan curve, or where do we get the fan curves at, things like that. Blue One actually has an HVAC database that's got probably over 60,000 manuals in it right now for everything from residential equipment through some of the largest commercial stuff. And you can download the IOM's installation operation manuals for those. And they also, interestingly enough, they have 24-hour technical support. So if you're ever on a job, and they actually support everything from mini splits to, they have guys that specialize in process chillers and everything else. They have a very interesting eclectic group of people. They probably have about 25 service techs down there that actually have a very good tech support background. So if you're, and I don't care how seasoned you are, you're gonna run into that something sometime where you just scratch your head and wondering what it is. And you can literally pick up the phone, and some of you will be on the phone within about 2 minutes. Blue On has been working on this for a few years. They've got a lot of industry support, but it's a pretty interesting application. But the whole thing is with these smart probes, right? You've got to ask yourself, well, how smart are the probes, right? You take the Tesla Smart Probe, and it reads temperature. It's about as dumb as that gauge is, all right? So literally what most of the manufacturers did was they took a display that was on your meter and they moved it to your smartphone. And that was interesting, but it really wasn't that practical, right? And that's why when you looked at, like, Fluke came out with some Fluke meters that connected to your smartphone, nobody really knew what to do with it. They really never took any market share at all, and that's where we really came in with Measurequick and tried to change the game. So the idea now is we're having a tremendous shortage of qualified labor, and it's like, how can we bridge that gap, right? Tom's in here every week teaching the fundamentals. And why is that? Because we don't have people that know the fundamentals that can actually be successful in this industry. We got to go back and literally teach the basics to the newest guys coming out, because when they went to trade school, they were taught the mechanics of things, how to use a screwdriver, how to braze, how to tell a 5/16 screw from a 1/4 inch screw, the left snips from the right snips, maybe how to stand in line. but they were not taught the fundamentals of enthalpy and entropy and latent heat and sensible heat and standard air and all these things that really, once you understand what we do for a living, are so important what we do. So the idea was to take some of this diagnostic technology and get schools to embrace it, because we can take all the years of experience a guy like me has and put them in the back pocket of a technician, right? The biggest things we want to talk about, and I was on the phone with a guy today, he's like, well, wait a minute, I'm really curious, how much longer does this take to commission a system? And my question is, well, how are you commissioning the system now? Because if you're just flipping on a switch and making sure it blows cold air, it's definitely gonna take you a few more minutes. But there's really only a couple things we can adjust in the system, which is what? 2 things we can adjust.
Charge and airflow.
Charge and airflow, right? So if you're gonna commission a system, we're pretty much just verifying a proper installation, verifying proper piping, pipe pitch, oil return. But at the end of the day, there's only 2 things we gotta get right, which is charge and airflow. I worked, again, one of the larger mechanicals in Cleveland, Ohio, and we were told at one point, don't even worry about airflow because it's set by the airflow guy, the air balancer, right? And I think for about 15 years, most of the problems I was chasing around were airflow problems that were just overlooked. I think it's by far, in the commercial segment, which I know a lot of you guys are, that is one of the biggest problems in the industry. And we're talking about, even building pressurization, the amount of energy waste from either over-pressurizing or depressurizing facilities is amazing. And with our heightened awareness of things like COVID today, really getting into the air side, addressing the filtration, the ventilation, all those kind of things are really, you can't overstate how important those things are. Couple things about Measurequick we're doing. We obviously connect the Testo, Field Piece, Redfish, Tech, Back Rack, CPS. We got some products we tie in with.
UEI, Parker,
Portland, yeah, there's others on there, but these are the big ones we tie in. Blue Flame, and all these tools can be used at the same time if you want to use them at the same time. We're primarily used for air conditioning. Measurequick does do refrigeration. We have a pretty cultish following for the refrigeration side, the gas heating side, and we can do heat pumps in the heating mode. The thing with heat pumps in the heating mode is no matter what you do, this will get you in the ballpark, but you have to go back and check the charge in air conditioning. There's not it's not a limitation of the software, or it's a limitation of the equipment. The equipment's just not designed to be charged in the heating mode, right? One of the things I always want to reinforce here is that before you make any single measurement, before you hook up a gauge, before you hook up a thermometer, before you do anything, you need to know what the measurement should be, right? If you walked into your doctor's office and he's tells you to open your mouth and puts a thermometer in, right? He's gonna know that the thermometer should read 98.6 degrees, or he takes a temporal scan, maybe 97.5 degrees, but he knows exactly what that measurement should be before he makes it. In our industry, sadly, we're constantly hooking up gauges before we even think about what the pressure should be on the gauge. You should be able to tell me exactly what the pressure should be before you ever attach a gauge. If you don't know what it should be, there's no screw that you're gonna adjust to say, oh, the suction pressure's low, let me just turn it up a little bit, right? And this is a big problem we run across in the industry. So Measurequick, what we've done with it is we've designed it so we can calculate all these targets, and every measurement we make has a acceptable range. And then when things are out of range, we generate what are called minor and major faults. So when you have a series of faults like this, like in this case here, we have high subcooling, we have a low liquid line temperature, and a high head pressure on the machine. Those 3 faults, and you look at them in aggregate, tell us what? What do you think would be a good guess for that? If the liquid line temperature is low, what are we doing with the liquid in the condenser? Stacking it up. So we have high head pressure because we just reduced our condensing space, right? We have high subcooling, so what's that tell us? Overcharge, right? Now, everybody in here, I know you're all seasoned enough, you know this, but it took you a second to process it, because you gotta think about, well, wait a minute, let me not look like an idiot and say the wrong thing. But the thing is the software knows what's wrong before any of us know what's wrong.
Yeah, I
When
was
you
saying,
look-
just switch to the probable causes. and then-
Switches to the probable causes, correct, yep. Now, a couple of interesting things when we start using software, because people, sometimes I'm called, tenacious, and other times I'm called obsessive. So when I'm looking at what we can do, what we should do, I always look at if a computer can calculate it, then let's do it the hardest way possible, right? Most amount of effort, because it's gonna give us better results. Anybody ever work at altitude at any Denver or in Colorado or any high altitude? I know Phil's probably seen a high elevation temperature pressure chart, right? Cause they published them when we were young boys.
Yeah.
Yeah, so you could get a pressure temperature chart for altitude. And because, what type of gauges do we use? Relative or absolute?
Absolutely.
Differential
Well,
pressure
we should
gauges.
use absolute, but
They're-
all of our
Technically, they're
gauges are-
differential between there and atmosphere. What
Yeah,
you're reading
they're
in
relative, they're relative to, when you zero out a gauge, if you zero it out in Colorado, right? It's definitely not, the same as a zero at sea level, right? So these gauges that we're doing, they're all relative, so what we had to do, because we couldn't adjust the relative gauge, was we would adjust the temperature pressure relationship of the refrigerant. So they had pressure temperature chart that was typically above 2,000 feet, and then they had another one for 7,000 feet, so you knew what the boiling relationship of the refrigerant was.
But in a sealed system, it shouldn't matter.
You know, it doesn't matter, but on the sealed system doesn't care, but your gauge you're hooking up does. Your gauge is a relative gauge, right? So
It's absolute.
you're,
No, it's not.
It's relative to the atmospheric
Think
pressure.
about how the Bourdon tube works, right? You have the pressure on the inside pushing out, but you got atmospheric pressure
Oh,
on the
it's
outside
PSI,
pushing
yeah,
in.
yeah, right.
Right.
You're right, it is absolute system, our system pressures are absolute.
Yeah.
But our gauges are relative, right? So, one of the things that Measurequick does that's unique, that you gotta watch, like if you go into set up a field piece gauges, a lot of people get the gauges and look at the temperature pressure relationship. And we have a refrigerant that has bubble point and dew point. Now, I always remember this, cause I always get this confused in my head, so, I always tell people, remember it as dew for heat and bub cooling, alright? Just if you don't remember, dew point is, for superheat, and bub cooling, the bubble for subcooling, when you're doing your subcooling calculations. You can see that Measurequick calculates the center of the glide. Now, when you're talking about a blended refrigerant, it doesn't act like a pure refrigerant, like R22 is a pure refrigerant, R410A is a blend. Most refrigerants are two constituents that are blended together. More complex refrigerants like Gluon are a 5 constituent refrigerant. And they're figured out that they can do some really cool things with these, but they're called high glide refrigerants. So what happens is, when it leaves the metering device, a large portion of one of the components of refrigerant will change from a liquid to a vapor as your flash gas. When it flashes off, it cools the remaining constituents down to the saturation temperature. And then those remaining constituents boil off at different levels. And at the end, you have the refrigerant leaving the metering device, maybe at 40 degrees, and when the last drop of liquid evaporates, it might be at 50 degrees. That would be 10 degrees of glide. We're not talking, we haven't superheated yet.
Yeah.
It's just the last drop of refrigerant has boiled away. So the last constituent of those 5 constituents has boiled away, that would be a 10-degree glide. If we had a 40 degree to 50 degree, what's the center of the glide?
25.
It'd be 45 degrees. Now, in theory, you think that was right, but
It's
in
probably
reality,
it's probably not linear.
it's not a linear relationship. Yeah, you have to take, I believe it's 30, I might get the formula wrong here, so don't quote me on the formula, but I think it's 30% of the dew point plus 60% of the bubble point equals the glide temperature. You can look it up, Emerson has it published in their stuff. So with Measurequick, because we're calculating the target pressure of the machine, we have to calculate the center of the glide. So if you're comparing your digital gauges, what you're gonna see is Testo and Fieldpiece show dew point and bubble point on their gauges. We actually show the saturation temperature. So we're calculating what you need to know, but we still use dew point and bubble point for superheat and subcooling respectively. right? Target superheat calculations for fixed orifice metering devices, specifically for fixed orifices. Let's say we have a return air wet bulb with 67 and a condenser dry bulb with 80, you're gonna get a target superheat, let's say at 20 degrees. Now what's interesting with this is this target is continually changing. As soon as you turn on your thermostat, what's the first thing in the room that starts to change? Humidity. You take your coffee, Jeremy, since it's mine.
Right.
All right, the humidity starts to drop, which means what else starts to drop? The wet bulb temperature, right. So as soon as we start that machine up, your superheat might go from 20 to 18 to 16 degrees over a course of 15 to 20 minutes. If you're not continually going in and getting a new wet bulb reading, you're not gonna get the charge correct. A lot of these machines are very critically charged today. And believe it or not, when you get into things like microchannel, things like that, it could be a difference of 1 degree of subcooling can be the difference between the machine running properly and a machine losing a tremendous amount of efficiency and capacity.
Ounces.
So ounces of gas can make a huge difference today. So Measurequick is running these calculations in the background in real time, constantly updating and showing you what the new target is supposed to be versus the measurement. Another one is our target temperature split calculation. This one's an interesting one because a lot of guys don't know this. You could start up a piece of equipment on a job site and you could have a split at 9.6 degrees and it'd be totally fine, right? You walk in there and you go, oh my God, I got a 9-degree split. What are most guys doing?
Add charge.
Slowing the fan down or adding charge. Now there's a mistake on this chart. If you can guess it, I'll give you a free piece of pizza. All right? It has to do with the far side of the chart.
Right?
Yeah, that'll be the right side. Very good, Phil.
He's 78 and 3/12 right now, so.
Yeah, me.
All right, well, we've studied it long enough. 70-degree return air dry bulb temperature.
76.
Highest it can be is a 70-degree return air wet bulb temperature. The wet bulb can never be higher than the dry bulb temperature. This is what happens when you give engineers Excel, right? They print out things like this and spreadsheets like this, and people get confused about this stuff because none of these readings here
Should have
took
dashes, right?
70, all these should be just wiped off the map because they're not possible. Wet bulb can never be higher than the dry bulb temperature,
Never,
never,
never.
not even on Tuesdays.
Depends what you're putting on your wet bulb.
Psychometric calculations. Measurequick does, obviously, your dry bulb, wet bulb, relative humidity, dew point, specific volume, specific density. Anybody know the relationship between specific volume and specific density? Yeah, Gary, it's not on your roadmap of things to know?
Not a clue.
They're very good, Phil. What are they, reciprocal of each other,
Yeah.
right?
Right.
So if we talk about a 1 pound of air occupies 13.33 cubic feet at
Standard
sea level
conditions.
at under standard conditions, right?
68.
And what are standard conditions?
68.
68 degrees Fahrenheit at
Sea level.
0% relative humidity at sea level. Okay, that's the standard, always 0%, 0% relative humidity is standard air. If somebody told you 50%, they're wrong. It's 0%. So, and now, here's what's interesting is, when we talk about that, you know, what we're talking about down here, let's say here's 68 degrees, right? We're talking about this line of specific volume. So it's equivalent, we'll see on the bottom of a chart, a lot of times there'll be a little dot right here, and they'll say standard air at the bottom. But anywhere on this line of specific volume is equivalent to standard air, anywhere on that line. Because the inverse of the specific volume, we said 1 pound of air occupies 13.33 cubic feet. Take the inverse,
0.075.
is 1 cubic foot of air is 0.075 pounds, right? So it's just a relationship on there. Now, this chart again is normal units at sea level. And so the problem is that most of us are never at sea level and most of us are never deal with standard air.
0% relative humidity.
I've never heard of zero. Is there such a thing?
Of course there is.
Oh,
Have you ever run a
That's
vacuum pump?
dry air.
well, yeah.
Okay,
Definition,
so
dry
it's,
air.
well, you are correct, actually. There is no such thing as 0% relative humidity.
In
We
the air.
we can never get all the moisture out of the air.
Right.
Now, in Arizona, they can run zero. But you sometimes will see it's, you just gotta keep moving the decimal place. Because we can never get all the moisture out of the air,
Right.
because it adheres to the wall surfaces, process called adhesion. But in our industry, when we're talking about zero, we're talking about 0.0.
In
Okay.
Tremco in the research lab, they had a dryer because they wanted to have the air testing stuff at a dew point of 100 degrees below 0 Fahrenheit. That's how
That's
dry
Jimmy's
that air
world.
was.
Yeah. Yep, Jimmy worked in, pharmaceutical, and they did, freeze dryers for cancer drugs, so.
Right.
And what was your evaporator temperatures, 100 what below zero?
About 100 below zero.
About 100 below
Well,
zero.
Mine,
Red
minus
Cross-
70 Celsius, so Fahrenheit.
Red Cross stores blood at 100 below zero. If I have a oddball weirdo thing and they do surgery on me, they'll take blood, when they get enough blood for
Wonder what the freezing point is.
Your blood,
during the
you get
operation.
you an old
They
guy?
store it at 100 below 0 Fahrenheit. So
Okay,
that's obviously a cascade system.
yep. Another interesting thing is normalization, right? And here's an interesting fact, when we're looking at, like, this is a 1.5 ton system, okay? So it's got a 600 CFM is standard capacity. If we run this all the way out here, this 18,000 BTUs, this is a 95-degree day, right? Condenser air 95. If we go here, this is a 67-degree wet bulb, 67, and go out here, it's 18,000 BTUs. Now, that is AHRI conditions. It's 400 CFM per ton, 95 degrees outside, 67-degree wet bulb, and that's equivalent to 80 degrees at 50% relative humidity. Outside of that, your system, this could be doing up to 21,000 BTUs of cooling, right? And over at this other end here, it could be doing as low as, looks like about 13, 10, 9,000 BTU sensible. It's a good total here, about 15,000, I think, is on the low end of that. So your 18,000 BTU system really doesn't really do 18,000 BTUs of cooling unless it's under AHRI conditions. So Measurequick does what's called equipment normalization. So we actually calculate what your equipment capacity should be based upon what the current load conditions are. So we look at outdoor temperature, we look at return air, wet bulb and dry bulb, look at your target airflow, whether you're doing 350 CFM a ton, 400 or 450 CFM per ton. And we run all these calculations in the background to assure that when you're comparing your actual capacity to what's called the normalized capacity. Now, this chart, though, doesn't take into account some other variables that affect capacity, which we do in Measurequick. Like, do you have 208, 230, or 240 volt? Anybody know what all equipment is actually AHRI? There's a specified voltage for all equipment. Anybody know what it is?
230?
230, there you go. So if you're at 240, right, think about a dimmer switch. You're turning up the light, you're turning up the speed of the compressor, you're gonna get more capacity. You're at 208, you're gonna get less capacity. Now, the equipment is also engineered to have a certain length of line set, typically 15 foot of line set. If you have a 15-foot line set, you'll get 100% of your capacity. If you have a 150-foot line set, you're gonna lose some. Every foot of line set is gonna cause additional losses of that equipment. That equipment's engineered for 400 CFM a ton. If you run it at 350, you're gonna have lower capacity, right? So line set length, your voltage, your airflow selection, all play into effect your calculations. And again, because we have a computer that can calculate this stuff, we do, right? Then you got your air density corrections. This is always interesting when you're looking at your standard, when you're looking at your IOM, installation operation manual. Do you ever stop and think that your static pressure is based on sea level? You're gonna have a different static pressure at elevation, at any elevation than you would at sea level. And again, we make the corrections for that. So when you benchmark a system with Measurequick, if it's a hot, humid day, we recalculate what your static pressure is going to be at 50% relative humidity and 75 degrees Fahrenheit. Yes, sir.
They're saying the article in the news that just came out, stop using inches of water column.
And used? Pascals.
Pascals.
Yeah. Yeah, Pascal, a Pascal of pressure is just a,
Damn French.
yeah. Well, yeah, it's a,
Well, you have real numbers instead of decimal points.
well,
We're
that's
talking about blower doors and, you know, positive buildings and negative buildings and all this kind of stuff.
yeah, I don't know,
For the
I think
customers.
I think it's the woke culture coming into heating and air conditioning, they're getting away from the zero units of measure. Let's use Pascals.
Why wouldn't they use millibars?
Yeah, no, it actually comes down to, it's just a finer resolution, right?
Yeah,
So,
but you're not using decimals. 0.10, 0.50, the residential system has a total, pressure of 0.50, so they just put that in pascals.
yeah, you remember in 1970, when we introduced the metric system on the cartoons?
It's gonna be right around the corner, yeah, right.
Yeah, and you see how well that worked for us, okay? So we should use a lot of metric measurements, but sadly, we don't, and I don't think the industry's ever gonna change. Because it's not a simple, when you look at all the formulas that we use for all the calculations we do, and the engineers that use this stuff every day, they're still using inches of water column. And I go back and I'm a history buff, I go back and buy all the old books,
Yeah, yeah.
all inches of water column, that's what we worked with, that's what the stuff was engineered and designed with.
And that whole psychometric chart, you can do that just in math, so you don't have to draw the, whatever.
Wasn't there a mix-up with the Hubble telescope because of that?
Probably,
Did they grind the lens wrong because they were using metrics in Europe, English measurements over here?
yeah.
Then they had to go back and give it a corrective lens or something before they could see anything?
In orbit.
So,
Yeah.
again, we're doing these corrections in the background of Measurequick. This is another interesting one, after Phil's heart here, right? Utilization voltages versus service voltages. And again, if you're gonna make a voltage measurement, you really need to know what it should be, if you're in the right range. We see this over and over again. We started doing this in the software, where people are actually finding out that they have significant voltage drops in their equipment when it starts. Remember, voltage is electrical pressure. So you never wanna test a voltage when the machine is off, unless you wanna get your service voltage, and then it'll
You're
tell
gonna
you,
get right up here.
right, it'll be right up there, but when it starts, there's an allowable voltage drop of about, 3%, is what we're allowed to drop in the line. And so when you test initially, and we gotta make sure that we're on the correct utilization range, so a 110 volt circuit could be as little as 110 volts, and it could be as high as 126, 125 volts, 124.5 volts, and it's totally fine, right? And
Well, there's two different things. One of them is what the electric company is guaranteed to do with PUCO.
Right.
That's plus or minus 5%. The motors, a lot of time, plus or minus 10%.
right, but your allowable voltage drop when if you size your conductors properly,
Yeah.
you have the voltage drop in your service.
You have a design drop
and
to
then
your
voltage drop in
service.
your branch circuit that you would consider when
Yeah.
you're designing your wiring.
In that lab, I've got a 100-foot cord, a 50-foot cord, and a 25-foot cord, and I hooked it up to a table saw. The voltage dropped down to 69 volts, and then it went back up to 95. And if I would run this table saw all day long at a 175-foot cord, it would be running at 95 volts
At 95 volts, right.
and overheat the motor like you wouldn't believe.
And it would overheat the motor because of inductive reactance, right? Not because of low voltage, or is it because the power factor's out of whack, correct?
No, because
I'm asking, not telling.
yeah, no, because of the power. If the motor needs X power, it's volts times amps.
Right,
If the volts go down, the amps have to go up.
the amps will go up,
Yes, they will.
they can't.
They do.
They sure do.
I've never seen that.
That's why you trip a breaker when you get
Yeah.
too long an extension cord.
We know that to be true.
I am positive.
What's the power stays the same, let me ask you a question.
Yeah.
If I dim the voltage down with a dimmer switch, right,
Yeah.
does my current go up at my bulb?
When you're dealing
We're
with.
talking about.
That's a different deal.
when you're
Okay.
dealing with
Because
motor,
there's three kinds of loads. There's resistive load,
Resistive,
so they're
inductive,
both go
capacitive.
together.
Yeah,
So at Vatterott, we had a, hot water tank that was rated for 208, 230. We're
Right.
running it at 208.
It's gonna draw
So we
lower
only
amps at
It's got
208.
lower amps,
Yeah.
resisted. Motors, the rules are different.
Right.
If you have to run at the motor speed is determined by the voltage and the frequency. The
Right.
frequency is 60 cycles, period, end of story. So if the motor is 60 hertz, it's gonna run at X speed. In order to run at that
Oh,
speed.
okay, yeah, I see what you're saying.
Yeah,
Alright,
A saw might not be the best example because your load's not constant when you're,
Well, it's
Cutting
any-
or not
it's
cutting.
any motor.
but I found, so based on that, you're saying if voltage goes down, amps goes up, right?
Yeah.
Yeah,
for
So on a-
motors,
For motors.
yes,
For
On a
motors.
fixed load, on a three-phase fan,
yeah.
if volts go
It's a
down,
motor.
if volts go down, amps goes up, right? But it's a fixed load at an approximate same RPM, the RPM is gonna be
if
closer
the
to
load's the
60
same,
hertz.
I guess
So-
that's where I'm looking at on a fan.
If
your load
voltage
increases
continues to go up, your amps will go up also, because you've got a fixed load and you've got a higher voltage and you're pushing more amps through that motor. There's a range where they're designed
Yes.
to run,
Yeah.
and
Yeah.
if volts
But
go
if
down too much, amps go up, but if volts are too high, they'll go up also.
If I take a 120 volt motor and I hook it up to 240, I'm gonna put 4 times the power in there. That's gonna burn that baby up in no time. Double the voltage means double the amps, means 4 times the power.
So you use a really
That's
long
toast.
extension cord.
That's toast. That's toast.
Wrapped around the
motor's
building.
gone.
I'm laughing because I was actually in a plant one time where a so-called electrician used a regular standard 110 outlet and took a Sharpie and wrote caution 240 volts on the outlet.
Well, you could wire it for 240.
Yeah,
that's what he did.
he was running 240 stuff on it, but
That's what he
But it was a
did?
standard outlet.
Oh, no.
Don't put the vacuum on there.
Oh,
It's gonna suck really hard for about 3
That guy
seconds.
should
Yeah.
go.
Oh, but
Well, that's illegal as hell.
Oh, man.
Electrician, huh?
But where's the police for that?
Yeah.
Yep. So then we get into the diagnostic side, the system problem side on here, and basically putting all this stuff together. And again, it goes back to, a lot of times we talk about, like on a fixed orifice system, we'll have, high suction pressure and high liquid pressure, and we know it has low superheat, low subfluent, we have an overcharge. But the thing is, if you don't know what the pressure should be, how do you know if they're too high or too low?
Yeah, how do you,
Right.
for that system, how do you know what normal is? That's what I always liked about those charts. Higher than normal this, lower than normal that, but how do you know where normal is supposed to be? Even with 2 identical pieces of equipment, how they're installed and everything else all affects that.
And this is why we actually benchmark equipment and capture the personality of the system, because every system that we install is a function of its installation. So when you look at the duct system that it's tied to, the power supply it's tied to, the line set length it's tied to, the filter type that it has, the duct system that it has, every single one is characterized by its installation. The idea behind this is if we can dial in how that piece of equipment is supposed to operate, then when things change, we can start to pick out the faults, right? And, well, I know, all of us have a passion for teaching. One of the biggest mistakes I think that we make today is we try and teach everybody the same way that we were taught. There's sort of a mentality in this industry that, damn it, this is the way I learned it, and this is the way you're gonna learn it.
Yeah.
And we're really trying to teach a generation of kids that use a GPS how to read road maps. And while there's value to it, we don't have time for it. And if you think about, back when computers first came out, all of us had to learn about EEPROM and RAM, and how to put RAM in a computer, power supplies, and
Input, output.
hard drives, inputs, output, cables, all that kind of stuff. Kids today, they don't know any of that stuff. They don't sure as heck how to use a computer.
DOS, what's
They,
that?
they can, well, we use Ubuntu, of course, we know what DOS is, right? So,
2.0.
not me, yeah. So, these kids today, when we're teaching them, we really gotta look at, can we leverage technology and get the output of people where we need it to be a lot faster, right? And that's what we're trying to do with this. One of the most important pieces of using software, if you're gonna use Measurequick, is probe placement. Where do you put your probes? This is a computer, so garbage in, garbage out. You put a probe in the wrong place, we're starting to detect these types of things because we can. So, we can tell, obviously, you would not believe how many guys in the industry today, they will call me and they will say, hey, your software's screwed up. Well, what's wrong with it? Well, it's saying I have my liquid line and suction line, or saying I have that I have my liquid and discharge line reversed. And I'll say, yeah. What's the temperature on your liquid line? Well, it's 160 some degrees. Okay, that's not your liquid line. That's coming out of the compressor, it's the liquid line. No, that's the
Since
discharge
when does
line.
liquid come out of a compressor?
When? Yeah, well, a lot of guys don't know, it's their first time on a package unit, and they see the pressure, the tap on the discharge line, and they assume because the pressure tap's there, it's gotta be the liquid line, and they put the probe, so we're actually detecting things in software today we never thought we would detect, because people make mistakes that we never thought they would make, right? So, we wanna make sure that we're on the correct ports. We wanna be on the true suction line, if we're talking a heat pump on there, right? Liquid line near the service valve, discharge line 6 to 10 inches away from the compressor, outdoor air out of line of sight of the sun, right? This is another interesting problem we get right here, it's called entrainment. We always, when we're using Measurequick, we wanna test from inlet to outlet, especially in an unconditioned space. The software will pick up duct leakage.
Yes,
And you'll see this a lot, where you're saying, hey, you might have duct leakage on your system. That could be curb leakage on a rooftop unit, because the curb's not properly sealed. If we're testing here, right, you look at this for just a second here, if we saw 75-degree air going in there, and we looked at it at 55-degree air coming out, we got 20-degree split, probably working just fine. In reality, if it was 72 degrees in that room, we just eroded 3 degrees of temperature split. And the software will pick that kind of stuff up. And so what you wanna look at, a lot of times, a couple things, when I'm walking into a space, mentally, I always look at the thermostat and sort of log what that is in my head. So when I look at my return air probe, if I see a much more than 1 to 2 degree difference, I'm starting to look for somewhere warm air is coming into the room, because whatever the space temperature is what my return air temperature should be. A lot of technicians make a mistake, especially when you're younger, in this, is you explain away everything that you see, right? You go, well, it returns up to the ceiling, and obviously hot air rises, so it must be hotter at the ceiling than it is at the floor.
Yeah.
In reality, there may only be in a well-conditioned room, it may only 1 to 2 degrees difference between the floor and ceiling.
we're talking about cooling mode or heating mode?
Yeah. Well, heating mode, you could definitely stack some heat at the ceiling, but on cooling, it's gonna be pretty evenly dispersed throughout the space.
Well, library, they have the air ducts under the floor, so you have all these deal like this.
Yep, orifices.
Yeah.
Yeah. So when we're doing this type of testing, we wanna make sure that we're in the supply duct. As the air comes out, even an inch away from this register, you're gonna start to entrain air as it comes out of the register, because you're gonna get a mixed air temperature. As soon as the air enters the room, it's called the Bernoulli effect, the high velocity air is gonna entrain air behind it, and you're gonna get a mixed air temperature. So you never wanna measure air temperature at the surface of a register, you actually gotta get it up in the supply duct. We test from the closest return to the closest supply, so we get a good air temperature measurement. Same thing here, right? Again, look at this, you have 70-degree air going in. A lot of guys are gonna put this probe up here in the attic, they're gonna say, oh, I got 75-degree air, 55-degree air, I got a 20-degree split. In reality, the split's only 15 degrees.
Why?
Because of duct leakage right there, we have 200 CFM of hot air from the 130-degree attic going in, eroding that temperature split of the air. This is one of the biggest problems in our industry, that people, by going up in the attic and putting the probes in the wrong position, we're missing the duct leakage issues on there. Whenever you have low capacity in Measurequick, it's a really good indicator that you have duct leakage on the system. Right? Profile the system. This is one of the most important steps. We're talking about after probe placement, is we gotta tell it what's your configuration, is it a split or is it a scroll? Does that variable airflow or not? In other words, does the airflow increase or decrease with the capacity if it's multiple stage? What tonnage is it? What refrigerant is it? What airflow is it? Nominal 400, or is it 350 or 450? What's SEER? What kind of metering device? These are all questions before you can evaluate the performance of the system that you have to have answered, right?
On that, quick question. I forgot to ask you this last time you gave this training. For your motor choices, it gives you ECM or PSC?
And we gotta add in, the, three-phase.
Three-phase?
Yeah,
Did we add it?
and also, well, there's some stuff, Measurequick, our primary customers right now, by far, are residential
Residential.
service technicians.
Right.
And so we've been working on some things over the years to make it better for that market. I'm gonna switch up here, I'm gonna show you, we have a whole new design of Measurequick, I'm gonna switch to just a second here. Measuring airflow, true flow grid, it's, we should probably do a separate class on that, but it's probably one of the most accurate ways of measuring airflow in the industry today. There's nothing more important when you're using our software than to make sure you're doing a thorough visual inspection. One of the other problems we see out there is guys that go out, deploy all the probes, and they overlook some of the most obvious things, right? One of them when I'm teaching this, one of the things I always have people look at is think about all these as subsystems. Everybody gets fixated on the equipment. They try and fix all the problems with the equipment. Well, you have a control system, which is your thermostat. You have an electrical system, an air distribution system, an air filtration system, a condensate disposal system, your seal system, your outdoor equipment, and your indoor equipment. And all these subsystems are impacting the operation of the equipment, right? We can do photo documentation in Measurequick. So there's a full photo documentation section in there. And as you're going through, you should be photo documenting things that are wrong or things that you see that, so you can document it for the reports on there, right? Let me go ahead, I'm gonna make sure, I'm gonna skip through a couple slides here and see if I've got, some stuff. I'll show you, I think I'm gonna just flip to the software and show you on the software. Let me see if there's anything else here we wanna do. The rest of them I'm gonna hit on the software. All right, interesting, by the way, just a little sidebar. It's a contractor in Arizona that uses Measurequick on every single job. They have about 600 service technicians.
Wow.
There are 7 guys in that room with 14 monitors and a third-party QC, QA, QC every single installation that goes in. And so the guys from the field are streaming data. These are their seasoned service technicians. You can see by the gray hair. And they're looking at the job, the pass fails, and if how the equipment's running and making sure that everything is operating before they leave the job site correctly. So what we're doing is changing. All right, let me flip screens here. We have just launched Measurequick 2.0, and we'll see if I can get this up on the screen. Let me get my glasses. Hold on a second. That's Mr. Waffles. All right, let's see here. I'm gonna have to switch to this, and we'll just go to QuickTime. I guess when we shut down here for a second, I action here, so we'll just go back here. All right. Oh, file. Come on. Okay, there I am. And so a couple of interesting things here. We have obviously tasks, which are things we would do. When we start testing a system, perform a quick test, view save test with your toolbox. Right now it pulls up a map showing that there's no equipment that's within a quarter mile of this location that we've serviced in the past. So the idea here is that we could create a new project, and I'll show you that in just a second, how that works. Also have a dispatch test, so if we're talking about like a Service Titan, we can actually plug in and dispatch a test from Service Titan. This is Test Tracker, so actually right now there's a guy from Gettle and a guy from Jackson Comfort streaming data to somebody remotely viewing that data. We could pop in and see what they're working on.
John Kluska?
Yeah, do you know him? I don't know.
John Whisker?
Measurequick Cloud, which ties us into all of our cloud services, a little bit of advertising, Measurequick Classic, latest videos, any products that work with Measurequick, training. So there's a lot of stuff in this page here. Everything on this screen is customizable. So if you wanna, let's say, move your equipment map to the top, you can grab this here and you can move your equipment map to the top. If you decide that you're not gonna use Measurequick Classic, you can hide it. If you wanna hide the latest videos, or maybe you know what's new and you know about Measurequick training, you can hide those things and you save the start screen. It's gonna be rearranged the way that you want it, and now it's a shortened version of the start screen on there, okay? So it's completely customizable. When we create a project now, we're gonna create a new project. It pulls up, do you wanna do a heating or cooling test? Usually you wanna start off with this installation retro commissioning. This workflow is telling us that we either wanna install a new system or retro commission an existing system that grabs some additional information about it. We can either add new equipment or create a new site. So in this case here, I would create a new site and it'll start the test. Now, one of the challenges we had with Measurequick early on was, I don't know where all this stuff came from. There we go. One of the challenges we had early on was, it was a lot of back and forth in the workflow to get stuff done. So I'm just gonna unlock this project here, and this is where we make our money. That's where we can do our system vitals or score, or our remote operation, that kind of stuff. I'm gonna do a couple quick settings here so you can see some stuff. Let me just put on some always show vitals just so you can see that, and we'll just, I think that's everything I wanted to do here. So one of the things that we would do here when we arrive at the job site is obviously we would deploy our probes. And right now Measurequick's saying it's waiting for tools. So it knows what tools are connected to it, and it knows when that system is stabilized. And then immediately it's running a score on the system. And the idea here is that we took a bunch of the industry studies that were based upon age and efficiency equipment, temperature split losses, static pressure losses, approach losses, and refrigerant charge losses, and how they impact operation of the system. So now we run a score that is an A through F on that system. So as soon as the system starts up, we're grading it. And then at that point, you can actually generate a vitals report, which we could share with the homeowner or the business owner what's going on and if there's any issues. So the idea here is that when we arrive at this job site, if we're setting up a new job, we would first of all mark the site, mark the middle of the building wherever we're at. This is site 38. We could change this to, what's the name of this this building here? This
305.
Let me get my hold on, keypad working here. Is there a name for the building? Kenmar Industrial Parkway or something like that?
No, the 303 is what's on the front of the building.
Groom Lake.
Groom Lake?
Groom Lake, that'll work.
I'm seeing the image.
So we'd say this is Groom Lake, tap on the customer information here, and we could, CLADD?
AA.
Glad Mechanical, Tom. And we'll just put a Tom at glad.com. I don't know if it's right, but for this it is. And a phone number. And it automatically pulls in the address. So that's our job site. That's gonna go green now. Now on the equipment side, what we do here is we would actually we can zoom in on the map a little bit if we want to, and we can see the equipment on the roof, and we'd actually drag and drop this right onto the rooftop unit that we're working on. And this might be here the office unit 1, whatever you want to call that. We put in our system information. Really important here, we grab the year that this was put in. So let's say
Where
this.
did you click there?
What's that?
Where did you click to get that? System information.
System information? Right here.
There you go.
All right, so system information. We're just putting in it's package or split, year was installed. We'll say this is just a train, and we'll say it's a YCD 090 LOAB. And then we'll just put, let's say, test in here if we want to. And we want to take a photo of the model number, serial number, we can do that also on there. System profile, so this is where we pick up 090 is a 7.5 ton, right? We'd say, in this case here, it's 410A. And most commercial stuff is not rated by SEER. A pretty safe bet is 10 to 12 SEER for a lot of the older stuff, closer to 13 SEER for the current stuff. If there's a different target subcooling setting in here, like maybe 9 degrees, we put that in. If we know the amount of refrigerant that goes in that system, we can put that in pounds and ounces. So we can, let's say 12 pounds and 3 ounces. That actually works for a charge assist that we have on this. Installation information, this is just location, is it on a roof or is it on the ground, is it zoned or not, does it have any belts on there? So if it has a belt size on there, you can say if it's got 1 or 2 belts. We also have a little calculator here. If you want to calculate your belt size, if the belt's broken, you can put in your shaft distance, your small pulley diameter, large pulley diameter. It'll calculate the belt size.
Is that pitch diameter or OD?
It's OD. And then you hit the continue on there. Electrical system information. So now this is, let's say a 3-phase. We'll do 460, 480, 3-phase. 460, 480, evaporator types, 3-phase. So it is there on the evaporator fan, it's just not on the other spot on it. If you have any capacitor information on this one, probably no capacitors on here, maybe on a condenser fan, but there's a spot for the capacitor information if you want to put that on. And then when you hit continue, that's filled out. Filter sizes,
Roll your finger down.
I'll slow it down. So you pick your MERV rating. So we got MERV 8 through 11 on here. Again, on filter sizes, there's some information built in. If you were curious, you know, what is MERV rating and how it ties in. We have a lot of what we call just-in-time information built into the application where to go out and pull in articles on what is MERV. So if you have to explain this to a customer or to a homeowner or whatever it is, we sort of tied in stuff that's right at your fingertips so you can reach out to it. And then the difference in MPR, MERV is, those are all tied in, you know, in these little sections here. So if you see little underlines, it's usually linked to something on there. If you use a filter media, you can obviously put the filter media in, and so we hit cancel there, and then we can put in the filter size. So these are 16 by 20 by 2s, and we had 4 of them. We could just put the filter sizes in. If you're putting in new filters that day, you just hit install new filters, that updates the date up here. And it can be filters in the return, or it can be filters in the cabinet, so we'll hit continue on that. And now we're this is a new section here we got, where before I test the system, we can add in notes and historical data. So we want to put in here, you know, this is a summer PM, and prime trap, and let's say that's maybe all we want to put in there. When you continue, that's gonna populate that. Now, if you do any corrective actions, so you can see it's here on the bottom here. If we do any corrective actions, and corrective actions will pull up a list. So the level of thermostat, verify the setback program, plug the wire penetration, tighten some wire connections in, maybe clean the evaporator, adjusted the fan speed, right? Replaced our filters, condensate drain. You know, what do we do with that? Do we clean and flush the drain line? All this information is going to be tied in. Clean your condenser, and maybe everything there was okay. We resolved the maintenance issues, resolved the airflow issues, and maybe the equipment's fine, or we recommendation. When we save that and we go back in this historical notes, if you tap on that, it's going to pull up those corrective actions that were done. So it's now become a historical record of everything the technician did while they were out there on that day. Any photo documentation, this grabs information so you can take a photo of the thermostat or whatever you want to take a photo of. So there we got Myron. You hit use photo. If we want to put any notes on that, we can put any notes on that, you know, plugged wire penetration. And if you want to tap on that photo, you can view it, delete it, whatever you want to do, but those will also tie in. So you got your thermostat, your electrical system, your air distribution system, air filtration, condensate, anything you want to photo document. Now these can also be accessed through this hotkey down here at the bottom. And this hotkey, when you click on it, pulls up quick access to your corrective actions. It pulls up to your performance of your system, if you want to look at your capacities or efficiencies. Right, so in this case here, we can look at our sensible. Now this is an interesting one here, because when you're looking at performance, can somebody tell me why the sensible capacity is the most important number when it comes to performance? This I will tell you for a fact is a liar for how the equipment's really operating. That could be at 75%, be totally fine. Why is that?
Depends on the latent, no?
Depends on the latent load. Latent load latent capacity is available when there's latent load to remove. Otherwise, the capacity goes unused. It's just sitting there, waiting for humidity to condense on the coil. If there's no latent load to condense, if you're above the dew point temperature, the coil's above the dew point, it's not, you're never gonna do latent cooling. So most of the systems in Arizona are operating at 75 to 80% of their rated capacity because they're set at 450 CFM per ton and there's no moisture in the air to remove. You can also have times when you're pulling out 100 or 200% of the latent capacity because the latent load is so high that it overcomes the, it just starts, you can't stop it. You can't
It's
stop
using
the
everything, we're using
Everything. for latent cooling.
So the temperature is not gonna drop if you've got 200% latent.
It's not gonna drop very quickly until it gets that latent load out. Access to your gauges, so if you wanna go to the gauges, access to your toolbox, so if you're connecting your probes or whatever.
Can you back up to the performance for a second, Jim?
Yep.
Please. How about scrolling them down? Those are all the airside performance and the,
Yep, so we've redone these so that,
Okay.
so they're boxed in, so here's your capacity calculations, your air site performance, your temperature split, your target temperature split, dehumidification in pounds per hour and gallons per hour. The software is calculating the filter face velocity, so it's looking at how fast the air is moving across the filter. And then also, if you input electrical data, there's an efficiency index and a capacity index. So basically what we're doing is calculating, if you look there, you can see the target condenser power of how many watts. We actually calculate how much capacity the machine's doing, how much efficiency it's doing, but these have to be tied in with electrical for those to read. And also your fan efficacy. Efficacy is, everybody says, oh, you spelled that wrong. It's efficacy is another word for efficiency, and it's just how many watts per CFM of air we're moving. Bypass factor of the coil, return air enthalpy, supply air enthalpy, your delta enthalpy. A standard change in enthalpy is about 6.66. Then we look at the return air, supply air dew point. You'll notice also we have the return air density and supply air density because we use those for capacity calculation corrections. So all those are at your fingertip on that performance side.
how are you calculating the enthalpy on that?
Enthalpy is it's the Hyman-Wechsler psychometric calculations. It's just a curve fit equation that's in the ASHRAE Fundamentals Handbook.
Dry bulb in, dry
That looks at
bulb
wet bulb and dry bulb.
Okay.
Yeah.
So, I mean, that's on the return side?
You mean how are we calculating BTUs
Yeah,
BTUs
yeah.
per hour? Yeah, we do it on return and supply, and then we measure differential output.
Okay,
Yep. It's just calculated
So if
from
you've
the
got
temperature
duct
and
leakage,
humidity.
that's off then.
yeah.
It's, what's that?
If you've got duct leakage, that's gonna throw that off.
Well, it'll
Especially
throw
if you're
off your
pulling
temperature
hot
split, it'll
return.
throw off everything.
Yeah,
Absolutely. Right? So all this hotkey is pretty important. Now, there's also some stuff here. Obviously, you can get quick access to your settings. You've got, in the settings, you got your units of measure. You've got your touchscreen indicators. So this is what, when we're talking about touchscreen indicators, this is what I'm doing right now. Keep the screen awake, your split screen view. This is set up, so if you want to make this third or half, and you want to change it to right or left, you can do that. So if you're left-handed, you like a little bit bigger workspace, you can adjust it. If you want to go back and you want to make it a third size screen, you can do that. So if we want to go back and make this a third, hit the check mark, you can do it. So if it's really user configurable the way you want to work. I like the gauges on the left, just happens to be, so that's the way I keep it set up. You've also got in your settings, you can change your button colors. All these Measurequick button settings are this, what's on that button. And we can also change the color of the button if you want to change the color. There's some interesting stuff in there. Pop-up fields, error messages, disable auto mapping, and right now the probes can connect automatically. This is handy when you're doing some training. This is always use sea level, and this is really like if you want to checker calculations, you can checker calculations against that. and then some things with images and targets and stuff like that. We've got an experimental AI engine we're building out that is artificial intelligence we're trying to use to do some diagnostics. So usually I keep that on there. All right, so in this case here, we put in some demo data, and you can see we got, because I used some demo data, the SEER rating's not possible, and the air handler voltage is imbalance detected, because when I put this demo data in, it's for single phase equipment. So it's already doing some diagnostics on that side, and on the diagnostic side of the equation. And if we go to test the system here, obviously we got all our outdoor and indoor measurements in, we put in our electrical stuff, and in this case here, we do phase-to-phase measurements. This is why I have an imbalance in phase, because this is all residential stuff that I put into this for the measurements. On the meter now, on the redfish, we have an auto capture, so you can literally move from L1 to L2. It'll beep and tell you it's got the reading. Then you move, detects when you take it off power and put it back on power, and it'll do all those different tests on there. We go to test the system. I'm just going to save a test out here and review the subsystems. It's automatically going to do the pass-fail. So in this case here, my electrical system failed because my utilization voltages are out of range, and I have a voltage imbalance on my system. So it detects the amount of voltage imbalance, in this case 15%, which would be pretty significant. It does your air distribution system, so it's looking at the temperature split, the fan watt draw, the total external static pressure, how fast your air is going to cross your filters. Some of these you'd have to do yourself, so if you're doing like a condensate drain, you'd pass-fail that. The charge, the superheating and subcooling are in range. You'd do your outdoor and indoor equipment condition. You would do anything you want on your notes you want to take. You hit continue, and if we hit generate reports, and now we have a Measurequick Pro report, a vitals report, corrective actions. We'll just go ahead and generate the Pro report. And what this is going to do is basically pull in the system score, any of the diagnostics. It'll break that score down with your agent efficiency losses. It'll explain, this is a little piece of paper explaining what these vitals are and why we're looking at the areas we're looking at. Pulls in the supporting documentation for the vitals report. So these are all your measurements, your high pressures, your low pressures, your subcoolings, superheats, capacities, calculations. And then any corrective measures that we did. So these are where we level the thermostat, verify the setback program, takes your photos. Well, who's that beautiful guy? And then any photos you got. So this is a typical report. Let me show you one I did today. If we go back to the home screen, so again, here we can go back to our settings or home, where we want to go to. I'm just going to go back one screen to the home and look at a report I did earlier. I think this was it for today. I'll just set it as active. And, oops, it's going to give me a little error down there. Okay, be that way. Yeah, we'll try this again here. It's because there's an update available. So the, let me try and pull this one test up again here real quick, see if I can get it. That one doesn't have photo documentation. This one does. Let me try and set it back again. All right, and then we'll go back in here, and we will just go to the, just go to the key. We'll go back one screen, back, and continue testing. I'm just going to pull up this typical report here. Hopefully it'll regenerate. I haven't tried this yet, but we'll see. Oops, that's what it's downloading the update in the background. Oh, sorry about that. Let me do it one more time. So this is like a typical report we might generate. You can see there's a lot of opportunity to do a lot of thorough photo documentations. In this case, we have a thermostat sub base needs plugged, or document wiring issues or anything else we want to tie in here, condition of the blower. A lot of times I'll grab capacitor information, so I've got it for later. Filter loading is just showing how the filter's loading unevenly on here. You know, anytime I also have the guys, when we're going out in the field, take photos of their probe positioning. It's really important if you're trying to do tech support, you wanna help a guy figure out what's wrong with the system, just to see where the probes are placed, so you can look at those later. So you see, we can get a really quickly and easily get a pretty thoroughly documented report. A lot of times too, I'll grab serials and, you know, model numbers, serial numbers, so I've got this stuff if I have to go back in and redo it again. And literally all this information's at the touch of a button, and I know it's a multi-page report, but a lot of times this stuff's just filed by email or filed in your company file. We're not printing things anymore, so it's just, having this at your fingertips is a pretty nice thing to do. Let me back up the screen here, and we'll see if we can, pick into one of the guys here.
Photos of label plates are always much better, you can check your dyslexia.
So, if you got a technician in the field, let me just throw some demo data back in here for just a second. And we'll just put some normal operation. Let's say your tech's all done, you wanna have them stream the data. Up here's a button where you can stream the data. And this is pretty interesting, because you can actually generate a shareable link. And so what you do with this is anybody that has Measurequick, like even your supplier, if you're wanted to show them something, you can actually send them a text with a link or an email or copy to the clipboard and even send it a Facebook Messenger. Anybody with a link in or out of your company can view it. If they're in your company, now you just gotta go to the home screen and you can see what technicians are streaming. I must have stopped my stream here. Let's see if we can tap into Nicholas's stream here. So I can see this tech, it looks like his system's off right now, or I can flip up to the next.
You're off, Jim.
They're all taking an extended lunch.
I don't know why I lost the connection.
Time.
Voters for
It's gotta be it.
Yeah.
You just killed the projector. My time is up.
Really?
all burned out.
Closing time. Last call.
That's all.
When it does that, it'll come back up.
All right, let me go back into my project here and I'll stream data from my project
Well, it's down, Jim.
Oh.
again. Yep,
We had a negative latent heat measurement this afternoon.
Yep.
Okay.
you evaporate the water off your coil.
We had 35-degree coil temp, and what was the wet bulb?
I don't need that.
65.
It could be also carrying water down the ductwork.
This was on a 20-ton downflow or upflow air handler.
You're looking at the supply,
Yeah.
49,
A wet bulb.
49.
So 35-degree
Coil.
coil. Yep. And 49. You said.
49 degree, 50, 49.9. What bulb?
You can have a negative latent, but normally that means one of two things happen. The compressor shut off and you're re-evaporating the water off the evaporator coil. Could also be that you have a non-intertwined coil. So you have a split coil with upper and lower, and the water as it's going down from the top is hitting the dry section of the coil and re-evaporating into the airstream.
Okay.
Seen that happen before. On a multi-circuit coil, you can have, if it's intertwined but it's not quite getting wet enough, that as the water drains down, it can evaporate and re-entrain into the air. Or you have a condensate drain that is with an improper trap, and you're trapping water in the evaporator pan, and it's re-evaporating into the airstream.
Sucking in.
We'll talk more about that.
Anytime you have negative latent heat, that means that you are re-entraining water back into the airstream. It's a pretty common thing to see, particularly when the equipment's off. It'll go, in fact, this is one of the reasons that in your home, if you're having humidity issues, the last thing you wanna do is run your fan all the time. Because as soon as the system shuts off, you'll re-evaporate all the water that's on the coil and re-entrain it back into the home. Alright, so now we're still streaming data. I'm gonna go back a screen here. Oh, that's what it's doing, it's stopping my data stream because I'm leaving the app. Bobby just must have updated that. So you can see any technician that's streaming data, and we'll try this again here. So what it'll do now is open up their data stream, and I can see, in this case here, he's got the system off, he doesn't have all his probes hooked up in here either. But I can see whatever he's reading on his probes, I can see remotely. We're just tapping in, I'm just peeking in on somebody that's, from Gettle here,
We can do this because we have,
access to everybody. This guy's just not streaming anymore. Jimmy, can you put some demo data on yours and stream it? Let me see, if we should be in the right same account. And when he,
are you in the Measurequick or the training account?
I'm in Measurequick.
I gotta switch. I'm in the training account from this morning.
We also have, company-wide settings now for the application. So if you wanna, in this case here, they're blanked out because, somebody's got control of my settings right now on here. And you can set up the company-wide settings and, enable all company-wide settings, or we can enable only the ones we want. And basically what this does, it allows us to set up everybody's tablet in the office the same way. So if we wanna set them all for the same units of measure, the same report choices, whatever we want, we can select that and turn those on or off. And it'll save those. You logged in?
And then probably start the project.
Alright, so we'll go back here. So the app has really changed to a hybrid of, as soon as Jimmy starts, put some data in here, we'll stream it. So there you can see Jimmy Emmerich came in, profile picture that's there. Let me get rid of this little craziness over on the side here if I can. Alright, we can tap on Jimmy and it'll open up his stream, and then if he's got some data in there, it should pop up on the display here. Put some demo data in yet? It may be because it's not seen.
Was this live, real time?
Yeah,
So what are these guys out west, or?
No, it's him right there.
Me right here.
that's Jimmy right there, streaming data. Yeah, so these are,
He's
these are the
gone
guys
back
in
in the
Arizona
measurements.
that are streaming
he's
data
doing
live, but
measurements
this is
in one
Jimmy's
too.
stuff.
Wow, he's a good-
So I can go in,
He's
can you
coming
put a
back.
demo data
It's a
with
demo
some-
thing.
a problem in it?
Yeah, I just changed the low side pressure. My
So-
low side should drop to 100.
And this right now is telling us the evaporator coil is gonna be making ice, right? So any faults that he sees, we can see, subcooling, superheat readings, performance of the system. So everything I'm looking at here, I'm looking at Jimmy's phone in his hand, from my device. Right, so putting the data streaming and things like this up in the front end have made it like a lot easier now to support your technicians in the field. So you can do this on a desktop, you can do it on a laptop, you can do it on a tablet, you can do it on your phone, whatever device you wanna do. If you wanna switch between techs, just click the next tech up and it'll go up to the next technician or whatever, you know, whoever you wanna open the stream from, and then back to Jimmy, and should go back to his stuff in just a second here. So that's probably one of the more powerful features we have on the system. Any questions I can answer for anybody?
And this is on the existing page that we're already up on?
Yeah, this is on the existing page. Now, once we get a system done, and I didn't save it, I got bumped out here well, let me go back here, we'll just do this. We'll exit this one, because I was in a different project. Project, yes. I'm gonna go back into the, view save test. I think this is the one I was just doing a second ago. And so this is applied mechanical, I'm gonna set it as active. So it allows you to go between them. I do wanna show you something here. Whenever you're done with a test here, we're just gonna exit and sync to cloud. Now, when we go back here, it's gonna save the report that we did, and it'll save some data here. Give it just 1 second until it goes back to rolling back in. We are saving all the reports, like all the photo reports and everything else, are getting saved to an S3 server now, so all that stuff's available at your fingertips. Gonna do 2 more saves here. One's gonna be of some data, and one's gonna be of the stuff. But now we come back here to this location, once it reloads here. Now it's got a pin on that rooftop unit. Remember before it said no equipment found at this location? So as soon as I arrive here, when it reloads the map, I've got the pin. So now I pick the office unit. If I come back to service again, I just hit start testing. Now I go into service, and it's gonna preload all that information about the profile, the geotag, the job site. and literally would just go in and check my filters. If I put new filters in, I would just hit install new filters, it would update the date, hit continue, and I test the system. And then, do this all over again. So now I don't have to type anything in, because this is now a record that we can reuse over and over again. Want to go back and look at the notes, you can see it showed when I started the project and when I ended the project, and summer PM for the trap, all the data that we captured from last time. So I want to see what the last tech did. I can see any of that data on here. These notes are private notes for the company, so only people in the company see these notes. So if you want to put notes about a customer or whatever, you can put those in into there.
Is that from the tech in the field to the guy on the desk too?
Yes.
Okay.
Yeah, the guy in the desk can see these same notes. So if we want to look at the desktop, let me just go back here. I'll go back out of this for a minute. We also put access to the desktop in here, on here. Let's go down a little bit to cloud. So this is Measurequick Cloud. Okay, log in again here. So this is the dashboard we use if we're a company. So this is where I could hit remote verify and it would pull up the live streams of the text. You notice there it also gives you a phone number. So Jimmy's phone number is there, so I know who I can call him if I want to call him and talk to him. And then this is the projects. So this will load up the company projects here. So this is the one we just did for Tom Steiger at Groom Lake. Now, you can't see my finger anymore, but it's the one with the green flag on it, okay? I can tap on that project, and I can see the notes. So this is the summer PM, right? I can see the reports that were generated. Now, if I'm on a desktop, I can actually pull up the full report that we did on this. On this one, you can generate the report again. So you manage your site, manage your equipment. If I want to edit anything here, this is where I can edit, and I can edit the full product details. So if there's stuff I want to edit on this, I can edit my service address. I can, anything I need to update at the office, I can do. And this can also be pre-filled out by by somebody at the office, so you don't have to type any of this stuff in. So if they have the information ahead of time, it can be pre-populated. And when you're all done, you just save that information. So we really made it a lot faster to access and use things, get access the cloud side and access the app side of the project on there.
So from that screen, how do you enable sharing, like if you want two people watching what's going on in the field?
So anybody, you just click on remote verify, and anybody in the same company can see the same information.
Okay.
Everybody at the same time can
As
see
long
it.
as they're logged into the
Yep.
Virtuos.
The
Okay.
same company.
We're doing a little thing here. Let me see if I can do it on super admin on this. I don't know if it's gonna come up here or not. No, all right. I was hoping I could pull it up here, but, it's on our dev site. I'd actually have to go to dev. We actually have, a way now to know when the technician arrives at the job, what probes were deployed, when the system is stabilized, what the score is of that system on there. So, and the whole idea behind this is to help level set the dispatcher. So it's a list of things coming out. System scores of 90%. We expect your technician to be out there for half an hour, 40 minutes to finish up a PM. System scores of 50%. It'll tell you what the faults are if you have a dirty condenser or an airflow issue or something. Or the system scores of 20%, it may be time to get somebody out to look at a equipment replacement. So the idea is to try and utilize some of this data to help level set your dispatching. There's also information here on the cloud for setting up your company. It stores the kinds of tests that you're doing, your qubit amounts, your permissions. So there's a lot of permissions that can be set, things like that. Your service type integration. There's a lot of different things on this that you can do. So it's just the whole cloud side of the business. You go right back into Measurequick on there. So there's a lot of new stuff on the software that we can do.
Outstanding.
All right, well, that's my 2 cents worth. Any questions I can answer?
Everybody got all that?
Yeah.
All right.
Everybody got part of it?
Yeah. Hey, if you ever think you have a bad day using Measurequick, you should try and program it, right? Bobby tears his hair out, Jimmy tears his hair out testing every day. We do a ton of testing. probably the number one thing I do every single day is go in and test and test and test and retest and redo calculations and redo math and make sure things are working right. It's a continual, labor of love to do all this kind of stuff, so. And we give a lot of it, almost everything you saw aside from the data streaming and the cloud storage is free. And a lot of people, we have over 70,000 techs registered using Measurequick now, across the nation, and
Very good.
we're just tapping into a tiny bit of the industry. So help spread the word and help us get this darn thing working.
Thanks, Jim.
All right,